Types of stress. Stress is a force that acts on rock to change its shape or volume. Stress on rocks can cause earthquakes. There are 3 different types of stress. The types of stress are tension, compression, and shearing. Tension occurs at divergent boundaries where plates are being pulled apart. Stress pulls on the crust and causes the middle of the rock to thin. Think about a rubber band being stretched out. The image on the left demonstrates tension. Notice the arrows are moving away from each other, just like divergent boundaries. The image on the right shows the Great Rift Valley of Africa, which was created by tension. Compression. Compression occurs at convergent boundaries, where plates come together. Stress squeezes the crust until it folds or breaks. The image on the left demonstrates compression. Notice the arrows are moving towards each other, just like convergent boundaries. The image on the right shows the Rocky Mountains, which were created by compression. Shearing. Shearing occurs at transform boundaries, where plates slip past each other. Stress pushes the crust in opposite directions, causing rock to break apart or slip apart. The image on the left demonstrates shearing. Notice the arrows are sliding past each other, just like transform boundaries. The image on the right shows the San Andreas Fault, which was created by shearing.
Faults can be separated into 3 broad classes based on the direction of the stress that caused the fault offset. When tensional stress is applied, the rocks extend, initially forming fractures, usually at an angle of less than 70 degrees to the surface. When the hanging wall drops relative to the footwall, it is called a normal fault. If compressive stress is applied to the rock, the effect is to shorten it. The fractures that form look a lot like a normal fault, but the motion is in the opposite direction. These are called reverse faults. When rock is pushed horizontally in opposite directions, the shearing produces strike-slip faults. Most strike-slip faults are close to vertical and involve little to no vertical motion. These stress regimes that act locally on faults also act at a larger regional scale to create the 3 basic types of plate boundaries. Tensional stress occurs at divergent plate boundaries, where 2 plates move away from each other. Examples include oceanic spreading ridges that form the longest mountain ranges in the world. As the plates pull apart, hot and therefore lower density mantle rock rises to support the 3,000 to 9,000 foot high spreading ridges. As the plates move away from the ridge, they cool, become brittle, and break into normal faults. Compressive stresses occur at a convergent plate boundary where 2 plates move toward each other. If 2 continental plates collide, they produce a broad uplift like the Himalaya mountain ranges with reverse faults parallel to the plate boundary. If an oceanic plate subducts beneath a continental plate, most of the faults occur within the overlying plate as it is compressed and buckles, forming coastal mountain ranges parallel to the plate boundary. The sloping contact between the plates is under high friction as the subducting plate shoves the overlying plate backwards. Shear stress occurs at transform boundaries where 2 plates slide horizontally past each other with strike-slip motion. Transform faults link offset boundary segments. Most transform faults are found in the ocean basin where they connect offsets in mid-ocean ridges. Transform faults can also connect a spreading ridge with a subduction zone, such as the San Andreas Fault that separates the Pacific and the North American plates.